LLMs, since, well, pretty much since OpenAI released ChatGPT, the LLMs that we're working with have not actually gotten any better. We've had a lot of refinement, but the LLMs themselves, the models, are marginally. They've just had refinement. They've gotten a little better, but not like any breakthrough or anything like that better. It's just the same stuff that they've been releasing since 2022. Why do I say it? Well, when you look, they've already trained on all the data on the internet. They stole copywritten works. They're being sued for that, and they trained on that stuff. They haven't gotten any new big, huge data sets or anything like that. And even if they did, it's still just next token prediction. The fundamental LLM itself is still the same thing that has been released for a long time. So who am I and why should you listen to me? Well, I'm Jake Watkins. I'm a software developer. I've been doing this developing software for about 30 years. And somewhere a few years ago, I decided to start playing this YouTube video game to see how high a score I could get. We're still making progress. But this channel is about talking about technology. And right now, the technologies to talk about are peptides and AI. And this is about AI, obviously. So to understand where I'm coming from on this whole point, that the LLMs are not getting any better at this point, we need to do a little bit of a history lesson. So we go all the way back into the 1800s when linear regression was first described. And all linear regression is it's a statistical method of basically drawing a line through a set of data that keeps the line as close to the data points as possible. It's something like least squared. It's not something I do all the time. But the interesting piece is as soon as you start studying AI or machine learning, you're going to hear all about linear regression. That's critical to this stuff. And that's all the way back from the 1900s. I mean, ancient history at this point. 1800s, not 1900s, 1800s. Next piece is the neural network was first described in the 1940s as a mathematical concept. Okay, that's 80 years ago. So the idea that these LLMs are built on comes from the 1940s, World War II timeframe. All right. It wasn't until the 50s and 60s when the first implementations in machine of a neural network first start to appear. And the first application, kind of cool, I didn't know this, but they first used a neural network to remove echoes from telephone lines. So apparently when you make a phone call, at least then, you could hear yourself talking at the other end of the line. It's kind of like right now I have an issue with Google Meets where my speakers are up there, my microphone is down here, and it'll cause an echo. Well, the neural networks will cancel that out for you. So that's 50s and 60s. Again, we wait until 1986 timeframe when backpropagation gets introduced. It's unclear to me whether it was discovered or just rediscovered or whatever, but backpropagation is where you feed data through the neural network through multiple layers, and at the other end, there'll be some amount of error that gets introduced, and you go backwards through the layers, looking at how each layer introduced the error, and you correct the weights between the neural network connections. So each neuron has a connection to all of the other neurons in the next layer, and you adjust those weights based on the amount of error at that end. And that backpropagation of the error is how we train our neural network to give us the results we're after. So that's 1980s. I mean, Reagan. Again, wait around. 2012, we get deep learning, which is kind of a byproduct of the fact that all of a sudden, through the 2000s, cloud starts being introduced. Storage becomes massively cheap. We are storing terabytes of data. I mean, Walmart's data warehouse, one of the biggest in the world at the time that I got to do some stuff with it, we're talking, terabytes of data at a time that was not common. I mean, people weren't running around with a terabytes SD card at this point. But deep learning is enabled because all of a sudden it went from costing many dollars to store a gigabyte of data to fractions of a penny to store gigabytes of data. So all of a sudden you had massive amounts of data to train on. Kind of a big deal, very critical to what we're doing today. And fast forward another 5 years to 2017, when the transformer architecture gets introduced, and that transformer architecture is the underpinning of all of these LLMs. So that's, well, it's 2026 right now, so almost 10 years ago. The breakthroughs and stuff, there really haven't been any fundamental things as big as really the description of a neuron as a mathematical entity. And that's from the 40s, okay? And the interesting piece, stepping back, and I'm trying not to go down too many rabbit holes here, but when you look at sciences overall, physics, chemistry, biology, looking for those big, huge breakthroughs, it's been a while. We've been refining a lot of our science, and we're beginning to hit physical limits of our current science. The size of transistors that we're able to fabricate into integrated circuits, we're hitting physical limits. I mean, we're down to almost the size of atoms at this point. So we're not, probably, unless there's a fundamental shift in the science, CPUs, the silicon that we run all this stuff on, is not going to get a whole lot better, okay? So what you see happening now is we're building gigantic data centers. We're scaling up. We've gone as small as we can. Now we're going to go as big as we can. And under all of this is laws of thermodynamics, and you can't break them. So you can only scale up so far before you hit a ceiling. And, you know, we've already made the CPUs about as good as they're going to get. We're also, for these data centers, the amount of energy that they require is problematic. We're talking gigawatts of energy, cities worth of energy to run a single data center, and cities worth of fresh water to cool the data center is needed. So there's some real serious problems. And all of that is limiting the LLM and its evolution. The fundamental science has to change in order to make further progress. But you push back, you say, but Jake, my Claude code is so much better than what it was before. How can you say this isn't getting better? Well, I said the LLM's not getting any better. What has gotten better, and even that's going to have limitations, is the harness around the LLM. We've gotten much better at it. And the interesting piece to it is all of the stuff around the LLM is the prompt. We have gotten better at prompting. We are the ones who are getting better. When we first started writing prompts for our LLMs, people were doing things like, oh, you're a senior software developer, blah, 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 blah. You're given all of this context stuff and then shooting that off at the LLM, and then it would respond to you and you'd get a result. And if you were good at it, you got an okay result. Well, today we've gotten better at those prompts, and we figured out you don't actually have to tell the LLM that it's a senior software developer. It'll figure it out through the context of what you give it. Excuse me. The additional things, tool calling. When we first started, LLMs, the stuff that went on drove me crazy. Not going to rabbit hole, cut this out. But we've given the LLM the ability to call tools now. But the interesting piece is when you dig into it and you look at MCP, it's just a prompt actually. So what happens is the MCP server tells the LLM, hey, here's all the tools and resources and prompts that I have stored inside me, and here's how to call them. So it actually tells it, it gives it a prompt saying, hey, if you want to, say, write a file, then say tool call, write file, and tell me what to put in the file and the name of the file, and I'll go do that for you. And the LLM in the inferencing loop will sit there and do its stuff, and it figures out, oh, I now need to write a file. So it goes tool call, write file, file name, here's the contents of the file, and the MCP server takes and parses that stuff, puts it together, and actually writes the file. But that's all software. There's no AI involved in that. Skills, right now, skills are the big deal. Well, it's the same thing. It's just a prompt. All of the progress that's been occurring over the last couple of years is we, the humans, have gotten better at using the LLM to get what we want from it. So what? Who cares? What do you want about? Why does this matter? Well, the reason I'm making a big deal out of this is a couple of things. First is the lack of progress, the real progress. Fundamental science has not made progress in a while. Does it mean that there's no more progress to be made? Absolutely not. It means that we have let ourselves get locked into a set of thinking that is limiting us, and somebody needs to break through it. And watching, I realized, not trying to rabbit hole, but looking at what's going on in healthcare, peptides. Look at all of the chaos being created because some biohackers are jabbing themselves with BPC 157 and healing themselves outside of the accepted normal way healthcare says it should be done. And it's blowing people's minds. And it's going to cause a revolution in healthcare. We need that same type of thing to happen in computer science and in AI. The LLMs are fantastic. I love working with Gemini and Copilot and Grok. They're wonderful. They're so cool. But they're as good as they're going to get. They'll get a little better, but honestly, it's marginal. It's, new paint stripes on your car as far as progress goes. We need shifts. Physics. I mean, one of the funny things is when you look into what these AI companies are talking about, what they need nuclear fusion. They need a breakthrough in physics so they can get nuclear fusion so that they can have their data centers. I mean, it's mind-blowing. And we've been 20 years away from a breakthrough in nuclear fusion for 80 years. I mean, it's the same thing over and over. You got Dario sitting there saying, oh, in 6 months, developers, all the code will be written by the LLMs. He said that a year ago. We're still 6 months away from that. And a year from now, we'll still be 6 months away from it. And that's the other point that I have here is if you're a software developer, I would be focused on becoming a better software developer. Get even better because you're going to have to be. The LLM is going to help you. The boilerplate, the stuff that already exists, it will help you deal with that. But the breakthroughs, the innovative thinking, that's on you. The LLM cannot do it. That's you. Anyway, I've nattered on long enough, and if you made it this far, I really appreciate it. If you've got your thoughts, you think I'm wrong, tell me how I'm wrong. I really want to, like I say, trying to find those changes in the mental model is critical to our progress. So let me hear about it. Anyway, please like, subscribe. I'll have more of this stuff coming out. And otherwise, you have a good afternoon. Oh, come on.